Okay, greetings everyone. My name is Yanak Pamungkas. Today we would like to briefly introduce our research. The topic is about constructing a property value index using Earth observation dataset over Jakarta capital city, Indonesia. First is that we would like to briefly introduce our curriculum vitae. This slide here briefly illustrate our current affiliations, expertise, as well as our laboratory. So we belong from the Center for Space and Remote Sensing Research, National Central University, Taiwan. Now for today's presentation, we'll cover 5 parts, ranging from the introduction, methodology, up until the conclusions part here. Now, for the introduction part here, we would like to briefly introduce our research background and problem statement. The first point is that urban land valuation is a key instrument to promote equitable spatial planning, but it's often compromised by these 3 issues, namely speculative pricing, data scarcity, and subjective assessment, which lacks spatial comprehensiveness. Jakarta, as the capital city of Indonesia, currently facing some issues ranging from rapid urban expansion as well as increasing housing demand with affordability gaps. So our research try to bridge those gaps, which compose of lacks of spatially continuous, updated, and reproducible approach that integrates environmental, structural, and accessibility factors, which something remote sensing and geospatial analysis can address. So one specific theory called Hedonic pricing theory, or HPT, which composed of 3 factors, namely structural, accessibility, and environmental factors, provides the theoretical basis and relating property values to their attributes, while remote sensing in this part will provide the consistent and scalable data backbone. Now moving on to the methodology part, this graph here illustrates our research framework, which highlight our research focus, independent variables used, input data, HPT attribute, and spatial analytical stages, as well as our research output here. So our research objective is to construct a reproducible property value index, or PVI map, using the HPT and multi-source Earth observation datasets. Now, for the dataset specification, this table here illustrates how each independent variable specifies in terms of its unit, data source, spectrum, as well as its resolution of temporal and spatial resolution. So all the variables that we use here were selected from the globally accessible sources. So that means this approach or this method could be applied anywhere else on the earth. And the next step is that the results part. Here we justify how each independent variables correlate with the PVI itself, the property value itself. So we done some literature review of prior hedonic pricing studies, which guide us both the variable direction in the weighted PVI model and the interpretation of the spatial results. One of the examples is that the LST, or the land surface temperature, it has the negative influence. That means that area with higher LST will have some thermal discomfort issue. That means that people will often have reduced desirability of that area. Now, moving on to the next part is that these 2 maps here illustrate the land cover map of Jakarta, which derived from the ESA world cover of 2021, as well as the spatial extent of each independent variables. So what we can learn from these 2 figures is that those 9 variables were built over the built-up areas, the right part here, and then LST, NDV, and NTL here reveal some degree in urbanization and environmental gradients. And another point is that both proximity and hazard matrix reveals some accessibility gaps, and as well as highlight some vulnerable zones. Now for the property value index map, uh, this map here, figure here illustrate the PVI values over the study area. We could see that the high PVI in Central and North Jakarta is often characterized by the high accessibility and built-up density, while the lower PVI exists across the peripheral areas with limited access compared to the north and the central areas. And the histogram here also has the right skewed patterns, which indicates that most urban land is moderately high in desirability. And overall, the PVI pattern reflects Jakarta's polycentric structure with multiple well-served districts. And moving on to the weighting results here, this table here shows us that each variable were weighted in from the two different approach of weighting methods, namely PCA and entropy weights. Those weights were averaged and then multiplied by its influence, so then we could get the final weight value to construct the PVI map. So what we can learn from this weighting result is that while green cover and urban vibrancy add values here, but the strong negative weights of flooding and pollution show that the risks outweigh the amenities, reminding us that resilience against environmental hazards has become the real currency of sustainable urban growth. Now, for the discussion part, here we list four key points of our research contribution. One of it is that this research provides a reproducible spatial modeling framework which applicable to other rapidly urbanizing cities. And we also note some limitation of some future research. One of the limitation is that we have yet to include some certain influencing factors, namely socio-cultural dynamics or policy changes that's not easily able to be seen from the remote sensing dataset. While for the future work, we also note that there's an opportunity for continuous monitoring to assess spatial-temporal shift in line desirability. As for the conclusion, first is that this study effectively demonstrates how remote sensing and spatial modeling can enhance urban land valuation through a reproducible property value index. And the second is that by integrating hedonic pricing theory with Earth observation data, this study bridges the gap between social science valuation and spatial analytics. And the third is that the BVI reveals meaningful spatial patterns of land desirability in Jakarta, which overcoming limitation of subjective appraisal and data scarcity. And the last point is that this approach offers a scalable framework for evidence-based planning and supports integration with socioeconomic and policy dataset for equitable urban development. And that's also show our reference in this research. And that's pretty much everything of our content. Thank you for your attention. Any comments, suggestion, or question are welcome in the following session.